Hello, everyone. Welcome back from lunch. Welcome to the final afternoon of Chicago Tech Summit. I, for one, get on a plane and fly back to rainy Seattle after I zoom on out of here, which will be fun. Thank you all for joining me for this afternoon's session on Microsoft's Advanced Threat Analytics. My name is Laura Hunter. I am a program manager inside of the Cloud and Enterprise Security Division. I've delivered a couple of other sessions across this Tech Summit. Some of you have been there for some of those other sessions. The Cloud and Enterprise Security Division inside of Microsoft is responsible for a cross-section, though not all, of Microsoft's security solutions. Just some inside baseball because it's fun. The very simple reason why the Cloud and Enterprise Security Division doesn't own all of Microsoft's security products is just a human aspect where I chain up to this wonderful vice president who has something like 12 people reporting to him. But if he owned all of Microsoft's security products, he would have something like 24 people reporting to him, and then he would never be able to get his job done. And so just by virtue of us being a large organization, some of our different security offerings are spread out across the Azure Active Directory team. Some of you have probably seen some presentations from them. The Azure Information Protection team. We are one big happy family. We all talk to each other, and we all compare notes. The team that I work for specifically, we are responsible for a couple of different security products that are designed to provide you with visibility, with reporting, and with the ability to set policy across a number of different aspects of your IT infrastructure. So we are responsible for Microsoft Cloud App Security, which there was a session yesterday. Microsoft Cloud App Security is designed to provide visibility, to provide policy, and to provide audits to give you as security professionals this type of visibility and control over your employees' use of software as a service, of SaaS applications. Similarly, Azure Security Center, some of you may have been in my session that I delivered right before lunch. Azure Security Center is designed to provide that same type of visibility, policy, auditing around your use of infrastructure as a service, platform as a service, so Azure IaaS, Azure PaaS. What we're talking about today, and this is the last of my trio, we're going to be talking about Advanced Threat Analytics, which is a tool that came out of the acquisition of a company a couple of years ago, a company called Aorato, which was a security startup based in Israel. And Advanced Threat Analytics is designed to provide you with visibility and reporting around threats that are specific to your on-premises Active Directory and DNS infrastructure. So we spend a lot of time talking about how do you secure the cloud? How do you secure the use of SaaS applications? How do you secure the use of IaaS? How do you secure the use of PaaS? Well, for those of us who are IT professionals, and as an aside, I've been with Microsoft for about 7 years, and I actually began with Microsoft as part of Microsoft's internal IT team. And so when I had people who are now in my role, when I had people from product groups coming to me saying, Laura, we want Microsoft IT to adopt the cloud because the cloud is the future and the cloud is where we're putting all of our investments, and go cloud. I, as the security curmudgeon, sat there across the table from them saying, but you do realize that all of our identity information and all of our core authentication and authorization infrastructure still resides on premises. It still resides in our on-prem Active Directory, which has been around for something like 18 years now. We've been running Active Directory since April 4th, 1999. We are the longest running and the oldest Active Directory environment on the planet. The US Army says they have me beat. I want to see their metadata. So this was the conversation that we had, which was, okay, engineering groups, you are looking to the future, and that's great. That's what you're supposed to do. And I hear you talking about the cloud is the future, and it is, and I completely believe that, or I wouldn't be working for a cloud service provider. But From a security perspective, if you've been in business for any amount of time, if you are any reasonably sized organization, the core of your identity infrastructure, the core of your authentication and your authorization infrastructure still resides on premises. And when we think about cloud adoption, and when we think about the security postures and the security measures that are necessary around cloud adoption, an inherent fact of cloud adoption is that your identity is your security boundary. There are no more firewalls. Well, okay, there are still firewalls at your border, but O360, there isn't a firewall that protects you and your little corner of O365. That's not how the cloud works. It's a shared service. And so when we think about how we secure, as customers, how we secure our adoption of the cloud, identity is our security boundary. And our identity information and our identity infrastructure becomes the thing that is most important for us to secure because it has become the thing that attackers are most interested in attacking. Think about spear phishing emails. Think about well-crafted web pages. What are all of these things trying to do? They are trying to grab your username and password because they know that that information, that key to the kingdom, which is your username and password key pair, is what is now going to allow attackers to find a way into your critical infrastructure, whether it's inside of a cloud service or whether it's by way of some sort of internet-facing endpoint into your on-premises infrastructure. Identity is so key, and identity is everything. And so we made the Aorato acquisition, which has now become Advanced Threat Analytics, as a way to help to secure your on-premises, your Active Directory, your on-premises identity environments as a way to better secure the end-to-end of your entire IT infrastructure, including your adoption of cloud services. Sobering statistics. I think everyone has seen these. The hackers are out there, and the bad guys are out there, and they have to be good once, and we have to be good all the time. The reason I bring up this slide, and the reason that I don't just glance off of this slide as marketing mumbo jumbo, is that very first bullet up on the left, which is the information that we've gathered by way of our product telemetry, by way of interviews with customers that we've helped both pre and post breach as part of our digital crimes unit. I think one of the big ways that attackers' behaviors have changed, if you look at the way attackers are behaving now versus the way they behaved 5 years ago, 10 years ago, is that they are no longer in it to jump in and hack a website and put a big splashy "Joe was here" on your corporate website as a way to advertise that, hey, you got hacked. They're not in it for the glory anymore. It's not it's not the teenager, and I used to be one, sitting in their basement trying to see what kind of trouble they could get into. This is big business. This is, frankly, organized crime could almost be considered a corporation at this point. This is organized crime. This is nation states. These are people, and these are attackers who are looking to find a way into your network and stay there as long as they can without getting caught. Because the longer they stay, the more likelihood that they will be able to exfiltrate something that is actually of value to them. And the thing that is of value to them is going to vary from target to target to target. They could be after your intellectual property. They could be after your financial data. But whatever it is that they are after, they are interested in finding a foothold in your network and then staying below the radar. On average, we are finding that attackers are staying resident on customer networks for upwards of 3 to 4 months, upwards of 140 days. There was a great quote a couple of years ago by the FBI director, and it was something along the lines of: there's two types of people in the world, companies in the world, those who've been hacked and those who don't know it yet. And my current retelling and my current spin of that is there are two types of organizations in the world: those who've been hacked and know what to do about it, and those who've been hacked and are trying not to admit it. So, these are statistics about the fact that attackers are real and attackers are out there, and as their attack vectors and as their behaviors change, we need to change to keep up with them. And so that's a big part of the reason why, as Microsoft has been building out the EMS suite, the Enterprise Mobility and Security Suite, when EMS first came around, some of you probably remember the S didn't stand for security. It was the Enterprise Mobility Suite. You remember that. When EMS first came into existence, it was the Enterprise Mobility Suite. It was some mobile device management. It was some elements of identity management. And it was collaboration tools. But we've realized, as we've gone on, that in order for Microsoft as a cloud service provider to really provide a holistic service to you, in order to really provide a service that is of value to you, our customers, so that we can make money. I'm renovating my house right now. I really like this notion of making money. In order for us to be able to provide value to you, we need to not only provide you with productivity solutions, we need to not only provide you with collaboration solutions, we need to provide you with the types of solutions that will allow you to secure your end-to-end infrastructure. Mobile device management was a first step in that direction. There is more work to do. And so when we think about applying that mentality to your on-prem infrastructure, to your on-prem identity infrastructure, what we think about is it's what we call the attack kill chain. And really, that's just a cool sounding phrase that security people like to do, because we like to pretend that we're on an episode of 24 and we're all Jack Bauer. But what it really comes down to is, when we have worked with customers over time and when we have seen how attacks play out against a customer's infrastructure, these attacks tend to follow a pretty predictable sequence of events. And it starts with some form of external reconnaissance. And this external reconnaissance basically means the attacker is looking for a foothold into your network, some way to get in the door. And that could be a very high-tech mechanism, like a spear phishing email, or it could be something very, very low-tech, like a social engineering call to your help desk, because your help desk wants to be helpful. The clue is in the name. Once that reconnaissance takes place, and once the attackers have figured out roughly the shape of your network, and more importantly, what an ingress point into your network is going to be, whether that's a weakness in your help desk systems, or whether that's a poorly secured external terminal server. Once an attacker finds their way into your network, the next thing that they're going to do is what we call the low privileged cycle, the low privileged portion of the attack chain. And this is what we call the lateral movement chain. This is where an attacker has somehow found credentials onto your network, and these credentials are typically normal user credentials. They don't start with admin credentials. They'd have to be really lucky to get admin credentials straight out of the gate. So we have credentials of a normal user on your network. The attacker has some sort of physical foothold into your network. And now they're just going to start poking around and prodding around and finding other places that they can use these credentials. Typically, this means that they will pop from one workstation to a second workstation. Oh, hey, there's a file server over there. Let me see if I can log in over there. Oh, great, now I can log in over there. And what they are doing at this point is they are investigating, they are trying to find some way to move to the next portion of the chain, which is what we call privileged escalation. And privilege escalation can be again, a very high-tech mechanism by way of being able to log onto a file server that, for example, they are able to latch onto some sort of process on that file server and be able to capture, to be able to attack administrative credentials of other admins who have logged onto that server. Sometimes it's far less high tech, and they find a way onto a file server that has a text file containing your passwords. Don't laugh, we see this all the time. All the time. By the way, if you're doing that, please stop doing that. As everyone runs out the door to make a quick phone call. No, you wouldn't do that. You wouldn't do that. And so at this point, we're in what we call high privilege escalation, which is, as an attacker, I now have some form of admin credentials. Great. Now I'm going to go after, the keys to your kingdom. I'm going to go after your Active Directory domain. Ultimately, my goal, or really my penultimate goal, is to become a domain admin, some sort of admin equivalent inside of your network. And the reason I say it's the penultimate goal is because that may be the technical end game in terms of security. But really the end game is, once I have owned your network, now I'm going to step aside and call my cohorts in crime who understand the actual assets that I am trying to exfiltrate, and I'm going to go let them do their job. Here, cohort in crime, here are some admin credentials on this network. Go and find that intellectual property you were looking for. Go and find those blueprints you were looking for. Because as an attacker, I'm an AD guy. I understand AD. I have given you domain admin credentials. Go find that Excel spreadsheet or that Salesforce database or that blueprint that you want. And this is what we call the domain dominance phase. And essentially, once we get to there, they exfiltrate the data out the door, and it's a bad day. The goal is that we try to help you detect what is going on and what is taking place in this kill chain before the attackers get this far. And really the purpose of a tool like Advanced Threat Analytics is that we provide monitoring and we provide detection of the kinds of activities that typify the lateral movement, so that lower end portion of the kill chain, as well as this higher end privilege escalation portion of the kill chain, so that you can respond and remediate accordingly. It is worth pointing out that ATA is not meant to replace protection mechanisms that you already have. It is not meant to replace your firewalls. Your firewalls are there for a reason, and they should stay in place. It is not meant to replace your anti-malware solution, your endpoint protection solution. Despite the fact that ATA and ATP are very similar acronyms, God, I wish we hadn't done that. They are very distinct tools, and they both have a place in your security arsenal. Really, the point of Advanced Threat Analytics is that it is designed to detect activities that are taking place on your network that may not be getting caught by these other mechanisms. Because the thing that typifies these attack chains is that in a lot of cases, they are using legitimate operating system tools. They're not using malware to scan your network. They're using a built-in DNS command. They're using a built-in Active Directory command. They may be doing a really good job of impersonating the behavior of an admin on your network. And so your existing tools, like your anti-malware tools, may and almost certainly do have a blind spot that ATA is designed to help you address. And so the way we do this is kind of twofold. The alerts that you will get from ATA, so the detections that ATA will bring to you, fall into two categories. There is what I call deterministic alerts, and there is what I call behavioral alerts. So deterministic alerts, the best way to think about a deterministic alert is, this is an alert which is, by any reasonable standard, an indication that something is going wrong, that something bad is happening on your network. Port scans, attempts to run ps-exec against a domain controller, evidence of pass-the-hash attacks, evidence of pass-the-ticket attacks. This kind of event, these types of behaviors are what we call deterministic alerts. ATA will be able to detect these behaviors within 20 minutes to an hour of you first installing it. And so as a part of my role inside the CNA security team, I spend a lot of time with customers helping them to install ATA, helping them to deploy ATA. And it is extremely rare. In fact, I can't think of a time that it's happened where I've installed ATA and it hasn't found something by the time I walk out of the guy's office an hour or 2 hours later. In most cases, and knock on wood, as will be the case for you, it is a low risk, low criticality item. To give you an example, the most common thing that I see within that first 20 minutes to an hour is an alert about the tool that you didn't know was running on your network that is using LDAP simple binds and thus passing credentials in the clear. So that is the sort of thing that ATA will pick up on very quickly as a deterministic indicator that there is bad behavior on your network, or there is at least poor application hygiene on your network. That's not necessarily a malicious event. That is a tool behaving badly that you should go and fix. The second category of event is what we call behavioral analytics. The canonical example of behavioral analytics is Laura is a PM working in the mothership in Redmond. She walks into work every day, 8 o'clock. She leaves around 5 or 6. And every day she accesses CRM and SharePoint and email because I work for Microsoft and I have to have my email or I will die. This is what I do every day. One day, Laura attempts to log in from an IP address in Elbonia at 2 o'clock in the morning and attempts to download the Windows source tree. Quick aside, how does Laura have rights to download the Windows source tree? Microsoft, don't you people manage your access better than that? I worked on the Visual Studio team for 2 years before I came to CNE Security, and some organizations do their deprovisioning of access and authorization better than others. I don't actually think I still have access to the Windows source tree because we're pretty good at that, but I haven't tried. Might be interesting to do that when I get back to the office. So yes, Laura is all of a sudden logging in at 2 a.m. from an IP address we've never seen her use, and she is doing something that is completely outside the normal band of what is expected behavior for Laura. This is what we call a behavioral alert. ATA will start giving you behavioral alerts after we have had enough runtime to establish a baseline of what constitutes normal on your network. And this is very important because from a design perspective, from a product design perspective, when we designed ATA, we very much did not want to fall into the trap of certain older Microsoft monitoring solutions that shall not be named, SMS, where you would install SMS, like a very old version of it, like version 1.2 or version 2, and the very first thing that would happen is that you would get 300 emails because there were all these things you had to do to tune it, and you hadn't done that yet. What's the first thing you do? You create a folder in your Outlook, you funnel all those alerts off to that folder, and you never read them again. From a security perspective, this does not move the ball forward. We don't want to put you in a position where you're going to ignore the help we're trying to offer. And so one of the design goals of ATA is that we provide you with self-tuning, so there really isn't any tuning of the ATA software that you need to do once it's been installed. Our goal is to provide you with self-tuning alerts that are low frequency and actionable, which is to say we're not going to set off someone's pager every time your firewall blocks a port. Your firewall blocked the port. It was doing its job. We're not going to set off someone's pager when that happens. Likewise, when we think about these behavioral alerts and when we look at how we are going to alert you as regards behavioral detections, we are going to sit and listen on your network for 21 days, 3 weeks. And during that time, we are going to build a behavioral profile database of the users on your network. Who's logging in? Where are they logging in from? What are their login times? What resources are they attempting to access? And we are going to sit quietly for 3 weeks and develop that database of information. You're still getting deterministic alerts during those 3 weeks. So a question I will often get is, what if the bad guys are already on my network? Does that mean that you are profiling their behavior as normal? And this is not actually a risk, because if a bad guy is on your network, I will give you 5 nines certainty that he is already doing something to trigger our deterministic alerts. You just don't know it yet. And so behavioral alerts will sit quietly for 3 weeks until we determine what is normal on your network, after which we will start reporting on what we see as behavioral anomalies inside of your network. And again, our goal here, as we look at the kill chain from end to end, we are not focused on preventing external reconnaissance. We are not your firewall. Your firewall is there for a reason. We are not your endpoint protection. Your endpoint protection is there for a reason and should stay there. We are very much focused on being able to detect activities that are typical of the lateral movement cycle and the privileged escalation cycle. What do we detect? We detect a whole bunch of stuff. And as we develop the product and as we build out new versions of the product, our goal is to release a new version of the product roughly once every quarter. Sometimes we're a little earlier, sometimes we're a little later. The product ATA as a product went into general availability on version 1.4 about 18 months ago. We are now at version 1.7. Version 1.8 is under development right now. When we think about new versions of the software and features that we want to build into the software, we're a product team. We have a backlog. You know, we talk to customers. We see what is important to you. At a high level, what we really look for as we're building new versions of the product are there new detections that need to be added? So attackers' behaviors and attackers' tactics change over time and develop over time. Are there new behaviors that we need to start alerting to? We also look for, are there ways to take existing alerts and to make them more useful to you? To give you an example, in version 1.6, which was the previous version of the software, we had a minor challenge with our pass the ticket detections specific to organizations that had extremely mobile employees. And so, for example, if I am sitting in Microsoft Building 9, and then I pick up my laptop, and the next hour I have to drive over to Building 27, and then sit down for a meeting in Building 27, version 1.6 of ATA would trigger that as a pass the ticket threat. It would come back as a false positive. Well, no, it's me, I just moved. And again, back to the whole, we don't want to inundate you with false positives because then we're going to be the boy who cried wolf, and then when we give you the thing that's actually actionable, you won't see it because you're ignoring us, because we're talking too much. And so what we did, a big thing that we focused on between 1.6 and 1.7 was to improve the algorithm by which we identified a given workstation or a given server so that we could, with much higher confidence, say, no, that's still Laura's workstation. She just went from one IP subnet to another. And so that's an example of something that was introduced inside of version 1.7. Other features to be aware of. We offer automatic updates of the software when we introduce new versions. The ATA server, the ATA console, sort of runs its own little mini SUS server, so that when a new version of the software comes down, that ATA center, and we'll talk about the center in a moment, will push out all of the updates and all of the updated agents out to all of the different agents that are running on your network. There is currently, and we're thinking about how we want to address this moving forward, there is one piece of the update process which is manual, which is to say it requires user intervention. When you update from one version of ATA to the next, you need to make the determination as to whether you want to keep your existing database of behavioral profiles, or if you want to drop it and start over. The trade-off there being, if you want to keep your existing behavioral profile database, during the time that the upgrade is running, and because this is now an upgrade of the database, it might take an hour, it might take a couple of hours. During the time that upgrade is running, you will not receive any detections at all. ATA will be effectively offline, so you will not even get deterministic detections. The trade-off being, if you decide to drop your behavioral database and start over, you've just started a 3-week clock running again. And so really it comes down to, depending on the size of your network, depending on, as we deploy new versions, it does not take us long to figure out a baseline of, for this size customer, we're seeing that a full upgrade is taking this amount of time, and that's the sort of guidance that we'll publish out to our blogs, out to our Twitter feeds, things like that. Integration with SIEMs. So if you already have a SIEM in place on your network that you're already using for security monitoring and security alerting, any alerts that ATA will show you, they appear inside of the ATA console, and I will show you the console in just a moment. But you can also forward those events to any SIEM or any managed security service that understands either syslog or the common event format. And the reason we did that, again, going back to Microsoft IT as our internal customer, and at the time I was part of IT when we acquired Aorato, and the Aorato guys came to us and said, here's our product, and we want MSIT to deploy it. And MSIT, meaning me, said, this is great. I love this information. This is so valuable. Please don't make me look at another portal. I get 250,000 events per day. They all come into my SIEM. I don't want to go look at your other portal. And so if you already have that information in place, if you already have that infrastructure in place, we can forward your ATA alerts to your SIEM. You can use your SIEM as your single pane of glass, and your security operations team, which is already monitoring their SIEM. This is just a new data feed into it. And again, that is any SIEM that speaks syslog or that speaks common event format. If you are using a SIEM that is one of the top 4 in the upper right quadrant, Splunk, RSA, QRadar, or ArcSight, we can also use those the SIEM as a source of information, and so we can ingest information from one of those 4 top SIEM vendors. So, key features, benefits. Benefits of ATA, we detect these threats very quickly using behavioral analytics. Again, once we've had that 3 weeks of runtime, we want to focus on what's important. We want to focus on those specific lateral traversal privileged escalation attacks that other aspects of your security infrastructure are probably not seeing right now. Again, we're not trying to be all things to all people. We're not an anti-malware solution. We're not an endpoint protection solution. You have those, and you should keep using those. This is an addition to your arsenal. We want to reduce the fatigue of false positives. We want to give you information that is actionable and meaningful. We also want to allow you to prioritize and plan based on the information that you see in any alerts that we give you. So when I show you the ATA console in just a moment, you're going to see in every alert that fires, you're going to see a description of the alert. You're going to see the users, the workstations, the domain controllers, all of the different entities that are involved in that alert. And we will also show you a set of recommendations coming out of Microsoft Security Services best practices. We will show you a series of recommendations as to what we think you should do next. Spoiler alert, it often starts with take the machine off the network and rebuild it. Not always, but often. And so when we think about deploying ATA and what an ATA deployment actually looks like inside of your network. ATA, as I've been stressing, is an on-prem product. It is designed to support and monitor your on-prem infrastructure, and so there is some hardware requirements, some server components required to deploy ATA. Architecturally, ATA consists of 2 logical components. There is the center, and there are the gateways. The ATA gateway, the best way to think of it is that it is a listener on your network. Depending on the size and the complexity of your network, you may have 1 gateway, you may have more than 1. This gateway is a passive listener. It is not in line with your authentication requests, so it does not add an additional hop to your authentication requests. You don't have to worry about scaling it up and high availability to match it with your Active Directory. It's not going to get in the way of your domain controllers doing their job. It's going to sit off to the side and listen for interesting traffic. And the way that it does that is in one of two configurations. There is what we call the full gateway. There's what we call the lightweight gateway. The full gateway is a separate standalone appliance, a Windows Server appliance that is running on your network that will listen to traffic coming from one or more domain controllers, depending on their performance characteristics. It can support one or it can support several. And it will listen for that traffic by way of either port mirroring or a network tap. So that's the full gateway. There is also the lightweight gateway, which is the same functionality, so the same general software as the full gateway, only it has been purpose-built and skinned down to run as an agent on the domain controller itself. And so a very common configuration that I will see is I will see customers who will deploy full gateways in their main data centers because they have better control over server footprint, they have better control over networking hardware. Sometimes you just can't get port mirroring done out in a tail site. And so they will put full gateways in their main data centers, and then out in their branch offices, out in their tail sites, they will deploy the lightweight gateway directly onto the domain controller itself. A couple of technical notes on the lightweight gateway. Because we have this running on the gateway itself, we were very intentional in the way we designed it to, number one, extremely performance limit it. It is extremely performance throttled. There is a certain amount of RAM and a certain amount of processor that the lightweight gateway will take up on your domain controller, but if your domain controller gets busy enough that ATA can't get the resources that it needs, it's not going to overrun the DC. It is going to throw up an alert. It is effectively going to throw its hands up in the air and say, y'all got too busy, I am dropping events, rather than getting in the way of the domain controller. We don't want ATA to get in the way of your DCs doing their job. We also very intentionally sandboxed the agent software such that if there is a software fault, we think we build our software well, but bugs happen. If there is a software fault, the gateway agent, that ATA lightweight gateway agent, will be able to go down without taking the DC with it. We didn't make it a hook into LSASS because we're not dumb. Score. So those are your gateways. And again, you can deploy the full gateway, you can deploy the lightweight gateway. Depending on the size, depending on the performance characteristics of your network, you may need one. You will almost certainly need more than one. Then we look at the ATA center. So if the gateways are doing the heavy lifting and listening to all the traffic, the center is the brains of the outfit. The center is what is receiving all of the traffic from these various gateways. The center is also what will receive information from your SIEM if you have one of those supported models. And the center is what is going to do all of the awesome machine learning, cross-cutting behavioral analysis, and throwing up a nice little report telling you what's going on your network. Does all that make sense? Any questions on that? There are no mics, so just yell and I'll repeat it back. Okay, so I've been talking a while, and I would really just like to show you what the software looks like, because I really think that gives you a really good indication of what the capabilities are of the software. So stay with me for just 1 second while I make the presentation laptop do its thing. Talk amongst yourselves. Okay, here we are. Here we have the ATA center. Can't see, I told you to duplicate. Why didn't you do that? Sigh. I told you to duplicate. It did this in my last session too. Okay, cool. Everyone can see that now. Awesome. So this is the console that is inside of the ATA center. And I've been told that ATA is the Facebook of network security tooling. I'm not sure how I feel about that, but I'll roll with it. And the reason that I've been told that is because when ATA starts showing you alerts, it does so in a timeline-based manner. And so you can very easily scroll from top to bottom to see current events versus newest events. What I'm about to walk you through is how ATA responded to a complete attack, all the way from beginning to end. This is a demo environment. The theory being, if this had been an actual emergency, the theory being that your security operations team would have caught on to this attack before it made it all the way to the end and responded to it. I would not, hopefully, ever expect to see an ATA console showing me the words, effectively, game over. So let's scroll all the way back to the beginning, and let's start at the beginning. So the first thing we see when we first installed ATA in this demo customer environment, the first thing we see is the thing I sort of already alluded to, which is the first thing I'm seeing is I have services running on this shared admin server that have exposed 13 account credentials in clear text using LDAP Simple Bind. This is that hygiene thing that I mentioned. There is some poorly behaved utility sitting on this server that is passing credentials in the clear. You can see within the body of the alert, you can see the server. You can see the domain controller that's involved. You can see the user accounts that were exposed. Everything is hoverable. Generally, as soon as you hover, what you will see is attributes of that object from Active Directory. So you can see I'm hovering over Gershon's account, and I can see his title, his phone number, his email address. I can also see information from within ATA itself. So I can see that Gershon has one suspicious activity associated with his account. In this case, it's this one. These items are all also clickable. So if I wanted to see additional details about this domain controller, like I wanted to see everything that was going on with this domain controller, I can click into it. And again, it will show me attributes from the Active Directory. It will show me its operating system. It will show me when it was added to the domain. This little green S is an indicator of sensitive. And what sensitive means is that we will throw a special flag on any computer or any user that is a member of one of the built-in Active Directory elevated groups, administrators, domain admins, enterprise admins, schema admins. We've had a lot of requests from customers to be able to customize what is included in that sensitive list. Like you might want to have your CEO's exec admin. You might want to have his or her account indicated as a sensitive object. That is not in the product today. It's something that we are very interested in, so watch this space. And so again, this is a summary of the domain controller. I can click through and see all kinds of information. I can see a summary of the suspicious activities that are associated with it. Because this is a demo environment and I only have one domain controller, it's all of them. But I'm going to go back to the main timeline. Go back, still go back. Keep going back. There, timeline. And so, as I said, we have this first alert, which is the LDAP Simple Bind passing credentials in the clear. I will say from the standpoint of the timeline of this attack, remember this event. If this were a crime novel, this would be the foreshadowing chapter. So we're going to scroll up, and the next thing we're going to see is evidence of what we call a honey token attack, or honey token activity. There is an optional, but highly recommended, component of ATA that allows you to configure a honey token account. So you create just a normal Active Directory user account, and call it something interesting. Call it admin, call it super user. This is your tar pit account, effectively. And then instruct your AD guys operationally to never touch this account, because any activity associated with it is going to get flagged inside of ATA. So here we see someone has attempted to log in as super user via this external vendor term TS server. We're still flagging this as low priority because it wasn't a successful login, it was an attempted login. But again, this is something that if you are monitoring ongoing, this might actually be your first indication that something has gone wrong. is there an endpoint on this vendor terminal server that maybe isn't as secure as we want it to be? You know, responding to these events is an exercise for your security operations team. But what this gives you is the visibility into events that we see as interesting. And even if we call something a low criticality event, it's not actually that low, or we wouldn't have called it an event at all. So low doesn't mean nothing to worry about. Low means you should get in there and look at this, but the building is not yet on fire, is a good way to think about it. The next thing we see, and we're back to this external vendor terminal server account, we're seeing reconnaissance using account enumeration, and this is a medium severity attack. And what I'm seeing is 105 guess attempts against user objects inside of my Active Directory. 102 of them don't exist. 3 of them do. Any security analyst who looks at this event is going to understand what's happening here. Someone is doing a breadth attack against my Active Directory, trying to find live user accounts. And again, I can hover over the server, I can hover over the DC, I can hover over the 3 live accounts that this attack was able to find. Because we're security people in the room, the next step of this is fairly predictable to us. They've found 1 live account as part of that breadth attack. They're now going to hammer in on that 1 live account in a depth attack and to try to hammer that 1 account's password. So I've gone from that breadth attack to now I'm seeing 450 guess attempts against Michael Dubinsky's user account. Again, we're at this vendor terminal server. Again, we're going against this domain controller. Now here's the interesting part, and this next event is the one that I think makes ATA so incredibly valuable. These 2 events that you've seen so far, that breadth attack and that focused attack, all of this is information that your AD guys already have. It is sitting in the security event logs of their domain controllers. Kind of hard to parse out, number one, especially if you have a lot of domain controllers, but more importantly, the thing that your domain controller security logs won't tell you is what happens next. So I see 450 bad password attempts against Doobie's account, and then they stop. Did the attacker get bored and go away? Or did they get in? Well, just on the basis of your AD logs, you have no idea. The next thing I see, Doobie's user account is logging in from 4 workstations he's never logged into before. He's logging into 2 servers he's never logged into before. He is logging in outside of what normally constitutes his normal working hours. He's trying to access 5 resources he's never tried to access before. This is that behavioral alerting that I alluded to earlier, the alerting that we need a couple of weeks of runtime to figure out. This is what makes this worthwhile, because this is what allows us to take information that is probably already resident on your network, but then overlay it with machine learning and behavioral analysis that, quite frankly, if you tried to build your own tooling to do, you would have built ATA. And we already built it for you, so you don't have to do that. And so here's what we're seeing. Here's what we're now seeing is suspicion of identity theft of Doobie's account. Unsurprisingly, if you read the recommendations, it's telling you to reset Doobie's password after you call him and ask him what he's doing. Really, I would just reset Doobie's password.
Can you automate all of this off of events?
So the question is, can you automate this off of events? So ATA today does not have any built-in system orchestration. However, you can, by way of SIEM integration, you can automate it that way. Also, if you are an OMS customer, so Operations Management Suite, if you install the OMS agent onto your ATA center, the ATA center will forward all of its alerts to the OMS system orchestrator, and then the system orchestrator will do what it does. It will run a script, it will block a port, it will trigger a runbook. But ATA itself does not today have any built-in orchestration capabilities. It's a fantastic question.
Can we go back 2 steps? And can you explain the difference between attacked accounts and potential guesses?
Attacked accounts and potential guesses.
So that's the same person, right?
Yes. UI artifact in cases where there's more than one. It's not actually not relevant to this case. But for example, if you were seeing, come back, go away, Mr. UI. So in this case, what I'm seeing is 450 guess attempts, and one that looks like it might have been right. I agree that something we could probably present better in the UI. We're security guys, we're not necessarily designers. All right, so sufficient identity theft. And at this point, the attack is just progressing, and these guys are off to the races. I've got a live account. I have his credentials. I am now hopping around the network, trying to take those stolen credentials and do other things with them. And now I'm back to this shared admin server. Remember that shared admin server? There was a song about the shared admin server. I'm now logging onto the shared admin server, which is still passing credentials in the clear. And it looks like I found some admin credentials because now I'm trying to log into one of your DCs. Again, my goal here is to show you the full extent of an attack. If this had been an actual emergency, my SecOps guys would have intervened. Certainly there. Maybe there. That's kind of the idea. Does all that make sense? Excellent. So from that is a demo of ATA. From a deployment standpoint of ATA, I've already mentioned that there is the gateway and there is the center. Let me get back to my happy little slides. That's the slide I wanted. Okay, so when you think about deploying ATA, as a product, first of all, let's talk about actually, purchasing and buying the product because, again, I'm renovating my house. I like my stock prices. ATA as a software is something that you already own if you are an EMS customer, if you are an eCal customer, or if you own ECS. If you own any of these things, you are licensed for ATA. If you are not licensed for any of these things, you can also purchase ATA as a standalone. But I like to think that we've cast a pretty wide net because, frankly, we want people to deploy this tool because we want you to be secure in your adoption of our on-premise as well as our cloud services. So the process of actually deploying ATA as a service, there is a sizing tool that is available on the TechNet website, aka.ms/ATA sizing tool. It's going to be in the notes on the slide. And this sizing tool needs to be run from a workstation in your environment that has network connectivity to all of your domain controllers. If you've ever had Premier Field Engineering come onto your site and do an Active Directory rapid assessment, where they have that little tool that runs, that does a whole bunch of remote WMI queries against all of your domain controllers, very similar moral equivalence here. So the sizing tool will need to run. It does need to run with domain admin or enterprise admin credentials because we need to be able to remotely interrogate your domain controllers. That is the first and the last time I will ask you for administrative credentials on your network. ATA as a service only needs to be a normal user account because we don't want the service that is helping to secure your network to itself become a security ingress problem on your network. That would be kind of silly. So, running the sizing tool, I need admin creds, and that's the last time I'll ask for them. The tool is going to run for the space of 24 hours. It's going to interrogate some static configuration items about your domain controllers. It's going to look for the number of cores. It's going to look for the amount of RAM. But it's going to run for 24 hours to be able to take samples over the course of that 24 hours of the network traffic that is being passed back and forth on your domain controllers, because that's going to be what helps to determine how many ATA gateways that you need, whether your domain controller can support running as a lightweight gateway. And so that needs to be run for the space of 24 hours. It runs for 24 hours. It spits back an Excel spreadsheet. Once you get that Excel spreadsheet back on that same link from where you downloaded the tool, we have some really easy tables to look up that basically says, if column B says this, you need this amount of RAM, this amount of proc, this amount of hard drive space. It walks you through it. It's very easy. Or if you already own ATA, frankly, call your Microsoft account manager and tell them to call me. Because one of the things that my team is chartered with doing is to help folks like you, people who already own the product, drive deployments and be able to actually deploy the product. So, if you own my stuff, I will help you deploy my stuff. I'm free, like a puppy. So, we make design decisions. How many centers do you need? The ATA center is a minimum of 1 per forest. I like to recommend, if you can get away with it, a maximum of 1 per forest, because multiple ATA centers today don't cross-correlate. So wherever possible, I like to see you have 1 ATA center per forest. The instances where I've seen customers go with multiple forests is when they have really egregious networking requirements. Think offshore oil rig. Like those sorts of scenarios, I've seen multiple centers. But for the most part, I would recommend 1 center per environment because that's your brain. And you don't want to have multiple brains that don't talk to each other. And then you install the ATA center. Installing the actual ATA software, click, 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 next, and you're done. The challenging part, or at least the part that tends to take time from what I've seen in helping customers install this software, is not anything to do with the ATA software itself. It's getting the prerequisites in place. How long does it take you to source the necessary VMs with the necessary proc and the RAM and the hard drive? How long is it going to take you, if you're using the full gateways, how long is it going to take you to set up port mirroring? The AD guys and the networking guys are often on different teams, and sometimes they don't talk to each other. This has nothing to do with technology. This has to do with people. So it's those prerequisites to the ATA, to installing ATA itself. Other prerequisites for ATA to keep in mind. I mentioned the service account. The ATA service account only needs read access to your Active Directory. So if you're using the default ACLs, you'll be in good shape. You will need to run 1 additional ds-ACLs command because we need read access to the deleted objects container, because one of the things that we trigger on is mass deletions of AD objects as a potential malicious act. But aside from that, normal user account, read access, a honey token account. If you want to use that capability, I highly recommend it. You will also need PKI certificates for the center and for every gateway. If you are using the lightweight gateway, that means a PKI certificate per domain controller, because your domain controller is your gateway. The PKI certificate needs to be server authentication. We do not need client authentication. If you've got your PKI templates more granularly locked down, we need a server auth cert for the center and for all of your gateways. And if you are not using a SIEM, if you do not have a SIEM in place on your network, we will also need Windows Event Forwarding configured from your domain controllers into your gateways. We need Windows Event Forwarding so that we can collect Event 4776, because that's what we use to detect past the hash. And then you install. You install the center. You install the gateway or the lightweight gateway for a proof of concept. For a proof of concept deployment, what I recommend is, and what I will help you with as soon as your account manager calls me, is I recommend installing 1 center and enough gateways to fully cover 1 Active Directory site. And the reason I recommend this is because if you have full coverage of that 1 Active Directory site, you can then perform your validations, your pen tests, set your red team loose on that 1 site, and that will give you indicative behaviors of what ATA will look like deployed across your entire environment. And then at that point, you install the software, you wait for an hour, you open up the console and see what it found. Hopefully, it only finds the little things, the LDAP simple binds. A question that I get, and it's a valid question, is what if we open up the center for the first time, and we see, oh my God, they're already here, and the security guy is falling off of his chair. Hopefully that won't happen, but I do want to emotionally prepare you that it might. And so in that event, so in the event that you open up the portal and you see this sea of red and oh my gosh, what do you do? Again, if you're engaged with my team, if you're engaged with the customer experience team, we have a very tight relationship with Microsoft's incident response team, so we can get Microsoft services onto your location, fairly rapidly. And we've just released something as part of some of our government contracts where we have a very formulated process by which we can go in and scrub your environment. It's this step by step. Reset all the passwords, reset all the curb channels, drop every machine from the domain and bring it back up. There are ways to respond. I bring that up because we're security people. We sort of have to think about worst case scenarios. Hopefully, you pop open the center and all you see is the LDAP simple bind thing that's going on. But don't ignore that, as we just saw. Resource sizing, here's the link to the sizing tool. That shortcut link is always going to have the most recent version of the sizing tool. I think the version of the sizing tool that we just put forward, we try to make it as easy as possible for you to just open the spreadsheet and understand the results. We actually don't want you to have to go, well, this said this, and then this said that, and I'm not. So the most recent version of the sizing tool has some very clear columns in it. Can run lightweight gateway, yes, no, all the way down your domain controllers. Needs more RAM to support the lightweight gateway, and all the way down. Needs 8 more gig of RAM, needs 12 more gig of RAM, needs 1 more core, needs 2 more cores. We try to make this, I'm trying to make it so that you don't need my help to deploy this software, because I want as many people as possible to deploy this software while still allowing me to sleep, because sleep is very important. And this gives you a look at what the sizing tool looks like. And again, it's going to run down all of your domain controllers and tell you about the sizing characteristics of them, whether they are good candidates for the lightweight gateway, and if not, it will help you size out full gateways. Things to think about for the lightweight gateway. Again, this is something that, because we don't want the lightweight gateway to overrun the domain controller, when we do our sizing exercise, the first thing we look for is this domain controller sending out more than 10,000 packets per second? And if it is, peace out. This domain controller is not going to run the lightweight gateway. Put in full gateways for this one. If you pass that first barrier, do you have enough RAM? Do you have enough cores? Do you have enough RAM? Do you have enough cores? Again, the sizing tool will help you determine that. Requirements for the center. So the gateways the gateways are interested in proc and in RAM. The center is interested in proc, RAM, and storage, because we need to create that database of behavioral profiles. And depending on the size of your network, the number of users, the amount of network traffic that you're issuing, this can be anywhere from a couple of hundred gig to around 2 terabytes, I think is the biggest one I've ever sized out. And that will allow us to keep that, that rolling 3-week count of profile information, of behavioral information. Anything else? Latest version of .NET Framework. You need certificates. We've already talked about the certificates. Other things to note about the certificates. The PKI certificates need to be configured not to auto-renew. ATA right now doesn't understand when a cert tries to auto-renew itself. It's on our list of things to fix. It also needs to be CSP-based and not KSP-based. Again, we want to fix that, but in the current release of the software, that's what we need. Current version of the software, again, version 1.7 is out now. We are building version 1.8. I've kind of already talked about some of the things that we've improved. We've added detection for SAMR reconnaissance. We've done improvements around pass the ticket and pass the hash to reduce the likelihood of false positives. Infrastructure enhancements that we've added in ATA 1.7. We've added roles. So we've added the presence of local groups that we create on the ATA Center so that you can have administrators of the ATA service as well as viewers of the ATA service. So if you have a security analyst who you want him or her to be able to view the results, view the output of the portal, but not make config changes. So we've put that in place for you. Top FAQs. What if you already have a SIEM in place? I'm going to submit that that the tooling that you already have in place, I've sort of already mentioned this. It is good and it is valid and it should stay there. The value that ATA provides for you is in catching those blind spots that those other tools are almost certainly not catching for you. We have telemetry and interviews from various customers that the average enterprise uses something like 16, 17, 18 different security tools on their network, and somewhere in there's going to be gaps that something is going to slip through. And this is a very common gap that ends up slipping through because, again, as part of this lateral traversal, as part of these privileged escalation attacks, attackers are not using malware to get this done because that would get them caught. They're using normal Windows tools. They're using things that are not necessarily detectable by the other layers of your security infrastructure. What do you do but I already have a thing, and how is this thing different from your thing? There's a 90-day free trial of ATA, even if you don't own any of the things I've already mentioned. There's a 90-day free trial. Set it loose, see what it catches. I'm highly confident it'll catch something you didn't know was there. What are the bandwidth requirements? So traffic going from the domain controllers to the gateways averages about 5% of the domain controller traffic. We don't forward everything. We just forward what's interesting, and that's going from the gateways to the center. If you're using the full gateway, obviously you're using port mirroring, and so at that point it's mirroring all traffic because we need to see all the traffic to be able to determine what is interesting to forward. But the traffic that's going over the wire from the gateways to the center is about 5% of the average domain controller traffic. The snarky answer I like to give when I'm on a conference call is Skype is taking up more bandwidth than ATA does. But really, it's about 5% of your traffic. Recap. There are blind spots. We'd like to help you fix them. You probably already own my product, and you should go deploy it. And if you don't own my product, there's a 90-day trial, and you should go deploy it. Okay, we've got several minutes left. As I mentioned, there's not any mic, so I will just yell. I see one, I see two. One.
What format is the user data you're storing the profiles?
What format is the user data that we're storing our profiles in? It's like you know the answer and you want to laugh at me. It uses MongoDB, which is an open source database, which is what the acquired product, Aerato, was already using. It's on our list of things. It's on our list of things to do to move it over to SQL Azure. But frankly, on my backlog, if I'm gonna create an awesome new detection for you, or if I'm going to change my database format, I'm gonna pick an awesome new detection for you.
Is it at least encrypted?
Yes, yes, sir. I saw two over there somewhere.
You commented about if you already own these things, you probably already have ATA. Can you go through that list again?
Oh, sorry. Didn't realize that was the whole of the question. Yes, so I mentioned if you already own certain things, you already own ATA. So if you are an EMS customer, so if you're already using EMS, you are licensed for ATA for your on-prem environment. If you already have eCal which is that big suite of you get to install a whole bunch of stuff from the volume licensing site, and ECS, which is a variant of eCal. If you are enrolled in one of those three things, and if you don't know, your account manager will be able to tell you that. If you own any one of these things, you are already licensed for ATA, and you should go install it. Or if you are not already a customer of one of these three things and you still want to purchase ATA, it can be purchased separately. It can be purchased standalone. Yes?
Any special insights or connection to ADFS?
Do we have any special connections or insights into ADFS? So ADFS is basically a layer of indirection in front of Active Directory as the authentication mechanism. So we don't monitor ADFS for anything in particular. We are monitoring mostly the Active Directory traffic. One of the things that we are interested in as a directional roadmap, like we're not there yet, but one of the things that we know we need to do is create better integration with other solutions inside of the security suite. So Azure Active Directory has its information protection suite in the cloud, which does some similar detections of what I've just described on-prem for your Azure AD identities in the cloud. We know that ATA and AAD identity protection don't talk today, and they need to. And so one of the things that we want to actively work on is basically allowing two-way communication. So I want Azure AD information protection to be an intelligence source into ATA. I also want it to go the other way. So if ATA detects that your on-prem credentials have been compromised, I want to be able to tell Azure AD about that so that they can take action. Today, that interaction doesn't exist. It's something we want to get to North Star directionally great by and by.
Even the on-prem ADFS, though, because right now that's where we integrate.
Nora, actually AD Connect has some of that monitoring on ADFS and Azure AD. It's something that they can look into.
Okay. So I have a colleague from my Azure AD team who just gave me information I didn't have because it's a big company and we move pretty fast, which is that Azure AD Connect, which is our utility for federation and directory synchronization into AD, does provide some intelligence and some monitoring around traffic that goes against ADFS. Thank you, Hyro. I didn't know you were there.
Yeah.
Sweet.
Perfect. And we also have some on-prem ADFS that's
Yes.
completely separate from Azure.
Yes, and Azure AD Connect will help you with reporting and intelligence against that. Sweet. See, we all work together, even when some of us don't get all the memos. It's okay. It's a big company. We move fast. Anyone else? I'm holding my hands up because I'm blinded. Yes?
And I don't really know how to phrase it exactly, but my basic question is, I'm surprised it's all on premises today. It seems like if this becomes a common way for all IT people to monitor their on-premises security, wouldn't it become an attacked feature of, not maybe malware, but something that they're going to try and turn this off so we can't see it? So how are you protecting yourself against it?
Ask me that again. Try that again.
My basic question is, if this is becoming common that we're looking to this tool to protect us against people doing bad things, how are you protecting this entity from being able to be stopped? Or can they attack your tool?
Thank you. I understand the question. Sorry, I needed to hear it a second time. So the question is basically, I have these ATA servers that are on-prem. How do I prevent attacks against the ATA server, either to stop it from doing its detections or even potentially to use it as a source of information? Generally, the thing that we think about there is, at a high level, it's still a server on your network, so you're still going to want to harden it just like you would any other node on your network. You're going to want it to have an endpoint protection. You're going to want it to have a firewall. You're going to want to monitor the holy heck out of it. From a standpoint of attackers specifically targeting ATA as a service, I haven't seen a lot of evidence of that today. I can't actually think of an example of where that has happened, but that is also a decision point between using that full gateway versus using that lightweight gateway. So if you install the lightweight gateway on the domain controller itself, and your attacker recons the domain controller, they're going to see, oh, this is running ATA service.exe. Whereas if you're running that full gateway, which is running as a separate standalone appliance, the odds of an attacker finding it are a lot lower unless they footprint your entire network exhaustively. So another security benefit, or a potential security benefit of the full gateway as opposed to the lightweight gateway, is that the full gateway is easier to hide because it's sitting off in the corner by itself, trying not to attract attention. It's a fantastic question. Anyone else?
The
Anyone?
ATA run on a nano?
Can the ATA run on
Nano?
a nano?
Nano server?
I know it runs on Core. I don't think anyone's ever asked me if it's run on Nano. I'm going to go out on a limb and say it'd probably work, but I don't think it's in our support matrix, because I don't think I've ever heard anyone ask me that. I'll go ask. That's an interesting question. I'll go see if my engineers have thought about that. Anyone else? Anyone else? This is going to look really funny on the video because I'm doing this, but I can't see anyone. Okay, cool. Thank you very much for your time, and enjoy the rest of your afternoon.